Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. And I'm Jeetendra Dixit. Here is my profile. So let me give you my short introduction. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. So I teach mathematics and we were doing complex geometry. I have already taken 2 sessions on that. Now this is the third session of complex geometry. So we'll continue that. But before we start, let me tell you about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform. And once you can have two types of subscriptions. Either you can buy plus subscription or iconic subscription. So when you get plus subscription, then you get access to daily live classes of all the educators who are teaching for IIT-JEE on Unacademy. You can watch their live. You can watch their sessions live, as well as recorded sessions also. You can download recorded sessions and watch them offline. You can ask your doubt during the live sessions. You can participate in polls. So these sessions are very interactive and very structured. Courses are very well structured. That means everything is pre-planned. You can see the schedule of all the upcoming lectures in advance. All right. So this is unlimited access which you get after buying plus subscription. These are the subscription charges. You can buy for 1, 3, 6, 12 and 24 months. 12 and 24 months prices, let me tell you, because these are the best packages compared to if you compare it per month wise. So 38,500 for 1 year and 56,000 for 2 years. And after 10% discount, you'll get this 10% discount using this code Jeet1. Use this code and you'll get 10% discount. All right. So you'll have to pay then 34,506 650 and 50,400. All right. Now this is iconic subscription. So in iconic subscription, you get all the benefits of plus. Uh, and apart from that, you get a personal coach who will guide you throughout your preparation for IIT-JEE or other top exams. And test analysis will also be done in a personalized manner. Personalized feedback will be given to you to improve your time management and exam approach. Your study planner will also be customized and bi-weekly reviews will be given to you, highlighting your progress. All right. So these are the specifications of iconic subscription. You can buy this subscription by paying 56,000 for 1 year, but you'll get 10% discount using the same code Jeet1. So 50,400 will be your final price for 1 year, and for 2 years it is going to be actual price is 86,000, but after 10% discount you'll have to pay 77,400 for 2 years. All right. So this is iconic subscription. This is the Unacademy's learning app, which you can download from Play Store. And after downloading, if you haven't bought any subscription, then there's no problem. You can still attend special classes. So every day there are a lot of special classes taken by top educators of Unacademy. So you can watch those special classes. Different topics are taken by the educators. So you can watch those topics. You can participate in practice sessions also. Okay. So these classes are called special classes, completely free, unlimited special classes you can attend. Just download this app, make your account and start learning. All right. Okay. Now let's begin our third session of complex geometry. Let me check my voice first of all. All right, so let's begin the session. Okay, so next curve is Z is a variable complex number and Z1 is a fixed complex number and Z satisfies Z minus Z1 mod is equal to, say, real part of Z. All right. Plus some constant you can take, plus k. The k is a real number. Okay. Let's take k positive also. But it's not a condition. K can be positive or negative. K can be any real number. So I'm writing k is a real number. Don't get confused with positive. K can be any real number. Okay. It might be 0 also. So this represents, in this case, locus of Z is a parabola. Okay. I'm writing the result first. Then Z lies on a parabola. And Z, then this implies that Z lies on a parabola. Alright. So let's see which parabola is this. So distance of Z from Z1 is basically, let's take Z here. So this represents mod of Z minus Z1. Now say if Z is X plus IY, okay? Then what is real part of Z? Real part of Z is X. And what is X, by the way? X is distance of Z from Y axis, right? So this is basically real part of, this is real part of Z, alright? If you take Z right side of X axis. And if you take k positive, in this case, suppose k is positive, let k is positive, then k will be this. If k is negative, then real part of Z plus k will be smaller than real part of k, okay? So I'm taking k. So that means real, see, this distance is, this real part of Z plus k represents the distance of Z from this line. What is this line, by the way? This line is X is equal to minus k line, okay? So if k is negative, then this line will be right side of y axis. If k is positive, then this line will be left side of. That is the only difference. There will be difference of diagram only. Otherwise, it's always distance from X is equal to minus k line. So what is this written? This is distance of Z from Z1, and that is distance of Z from X is equal to minus k line, or you can say X plus k is equal to 0. All right. If I take this k as a, then it will be, I mean, might be familiar, look familiar to you. Let's take this a. Okay. So this a, you know, so distance of a point, distance of a moving point from a fixed point is equal to its distance from a fixed line, right? X is equal to minus a is a fixed line. So these two distances are equal, right? I'm marking these distances again. This and this. So Z lies on a parabola. Z lies on a parabola whose directrix will be X is equal to minus a, and focus will be at Z1. So Z1 might be, I mean, if you want to make it a standard parabola, then Z1 will be a comma 0, right? If you take Z1 as a comma 0, then it will become a standard parabola, which you have learned. So if I'm taking this x1 comma y1, okay, shifted parabola basically, then Z lies on a parabola whose focus is Z1 and directrix is x plus a is equal to 0. Okay, x plus a is equal to 0. So if you want to write the Cartesian equation of this, you can write the Cartesian equation. So Cartesian equation is x minus x1 the whole square. I'm applying this point, say this point is p, this point is s, and this point is m. So I'm applying this ps square is equal to pm square. All right, you'll get the equation. So ps square is x minus x1 square plus y minus y1 square, and pm square is basically, pm square is nothing but x plus a. All right, the whole square. This distance is x plus a, this distance. All right, x plus a. Okay, so you can expand it, you'll get the Cartesian equation of the parabola. So I hope you have got it. Okay, so you can answer questions based on this. Now suppose equation is next, we are doing the same question, same parabola. Z satisfies if, I'm changing the equation, if z satisfies, if z satisfies z minus z1 mod is equal to, now in place of real part, like in previous equation I have given real part of z, here I am writing imaginary part of z. Okay, imaginary part of z plus a. Okay, so that is the only change. Now let's see, this is also a parabola. Okay, in this case also locus will be a parabola, but which parabola will it be? Let's see. So I've changed right hand side, real part of z I have replaced by imaginary part of z. Okay, so let's take z1 here. Okay, and a line, I'm plotting a line, and this line is y is equal to minus a line. Okay, so if you take z here, say z is this point. Okay, this point, then distance of z from z1 okay, this one, these two distances, this is imaginary part. So imaginary part of z is basically what? Y. If you take z is equal to x plus iy, then imaginary part of z is nothing but y, right? So in this case, in this diagram, y is nothing but the distance of z from x-axis. This is x-axis. All right, so this is y and this distance is a, right? This is a. So y plus a is this distance, pm. Pm is y plus a, right? PMA, PM, this is PM. This is nothing but PM. And this is nothing but PS. Alright, this is S. So PS is equal to PM. Now it's again a parabola. So it is a parabola whose focus is at S and is passing through. So this is a parabola like this. Alright, this is the focus. And here will be the axis. You can write all these things. Okay, so in this case, locus of z1, locus of z is a parabola. Locus of z is a parabola whose focus is, for what is focus? Focus is at z1, right? Z1 is basically x1 comma y1, and whose directrix is y is equal to minus a. So now you can write the distance between y is equal to minus a and z1. So if you want to write latus rectum, you can write latus rectum also easily. Latus rectum is going to be this point. This length is going to be y1, right? This is y1, y coordinate of z1, and plus this is A, right? So the lattice rectum is y1 2 times of y1 plus A, okay? Because if you know distance between focus and directrix is equal to semi-lattice rectum, all right? Distance between focus and directrix is equal to semi-lattice rectum. Is that okay? All right. Now I'll give you another equation. I'll give you this question in which you need to write. What is happening, man? The complex equation of a parabola, okay? Now I'm not giving you the equation, but I'm asking you to write the complex equation, okay? Say this is a line, y is equal to tan theta x. This angle is given theta. And parabola is like this. You need to make this line as directrix. And focus, you can take your focus of the parabola at this point S. Now this is the point P. So this is the point P. PS is equal to, you need to write PM, this distance. PS is equal to PM. Okay, this point is Z. How to write it? See, if I join this P point to origin. Achha, now what is special in this? This directrix is passing through origin. Okay. So I'm writing one of there is tan theta x. Okay. So I'm writing one of the equation of parabola in which this directrix is oblique or axis is oblique. Okay. Now previous two parabolas were horizontal or vertical. Okay. Horizontal means axis was horizontal, and vertical means second was, so in the second one axis was vertical, right? Now this this is a parabola in which directrix is oblique, so obviously axis will also be oblique. Axis is going to be this. Let me plot the axis. So axis is going to be like this. This is axis, okay? Perpendicular to directrix will pass through focus. So this is axis of the parabola, right? Axis of parabola. So we need to write the equation. This is your directrix. This is your directrix. All right, let's come back to this this origin. This OP is nothing but mod of Z, right? We know that equation of, we need to write the equation of parabola. Write the complex equation of parabola. Okay, so any such equation might be given in the option. Which of the following represents a parabola? Okay, so previous two you can identify easily. In this case, see, if I use this triangle in triangle OPM, okay, in triangle OPM, this angle is 90 degree. So PM is equal to OP, and say this angle. What is this angle, by the way? This angle is alpha. Okay, we'll figure it out. What is this angle? And what is this angle, by the way? This angle is this angle is basically argument of z, right? So you can write alpha. Alpha is nothing but theta minus argument of z, all right? So OP sine alpha is equal to PM, right? And we know equations. OP sine alpha is what? OP is mod of z, and sine alpha is what? Sine of theta. Theta is given, okay? Theta is given. This inclination of the line is given, and even the slope is even if slope m of this line is given, then you can write theta is equal to tan inverse of m. So theta minus argument of z. All right. So this is PM. So PS is equal to PM. PS is equal to PM. So PS is equal to, what is PS? This is PS. And this is PM. So we have got PM. Now PM we can write easily. PM is distance between this is given actually. Z1 is given. So what are the things given? Given is Z1. Okay, focus is given, and directrix. Y is equal to tan theta x. This is given, okay, as directrix. All right. So PS is equal to PM. PS is going to be mod of Z minus Z1, and PM is going to be mod of Z sine theta minus argument of Z. Okay. So in this way you can write the equation of a parabola in complex form. I hope you got it. This is very, very good equation. So now let's move to another curve. Locus of Z, if Z satisfies, we'll do problems based on equation of parabola, okay, which we have learned today. Three forms: vertical, horizontal, and oblique. Okay, so we'll do questions based on these equations maybe tomorrow. Today I'm going to cover the theory part. Okay, theory part, that means how to figure out the equations of parabola, ellipse, and hyperbola. Okay, so most probably we'll finish parabola and ellipse today. So locus of Z, if Z satisfies Z minus Z1 mod plus Z minus Z2 mod is equal to some constant, say A. Okay, A is a constant. Okay, let's take some other constant, K, not A. We will use for major axis. All right, major axis 2A. So it is equal to K. K is a constant. K is more than 0, obviously, and constant. Okay. All right. All right. So Z1 and Z2 are two complex numbers, two fixed complex numbers. K is a constant. So he's saying that Z is a variable complex number, and sum of distances of Z from Z1 and Z2. All right. These two distances, sum of these two distances is a constant. All right. I have made this triangle without knowing that this K, sum of these two distances, is whether greater than Z1 minus Z2, distance between Z1 and Z2, or equal to or less. Okay, less is not possible. because if you take any point in this plane, then its sum of distances from z1 and z2 cannot be less than the distance between z1 and z2, right? I mean, I'm talking about this. It cannot be less than this, okay? It can be equal to this if z lies on this, all right? Okay, so let's first condition we are applying this condition that k is more than distance between z1 and z2. Are you getting this point? So it is given. It is not I mean, it you will have to check this, okay? Now this will satisfy. I mean, when you'll check the distance, because z1 and z2 are given, k is given, so he won't tell you that k is greater than z1 minus z2 mod. You'll have to check it. So you will find the distance between z1 and z2, and then you'll compare it with k, and it happens that k is more than z1 minus z2. So that's at this point of time I am telling you that k is more than z1 minus z2 mod, okay? So if k is more than, that means yes, now triangle will be formed. So if triangle is formed, then do you know that in ellipse, sum of distances of any points on the ellipse from its foci is a constant, and that constant is equal to major axis? Yes. So if a variable point, if a point moves, now listen to this. This is the definition of ellipse also. If a point moves in such a way, that sum of its distances from two fixed points is a constant, sum of its distances from two fixed points is a constant, and that constant is more than the distance between the fixed points. All right. So sum of now look at this diagram. Sum of distances of a variable point from two fixed points is a constant. This is k. All right. And that constant is more than the distance between z1 and z2, distance between fixed points, okay? Then locus of that variable point is an ellipse, and those fixed points will be foci of the ellipse, and that sum of the sum which was constant will be equal to length of major axis. So locus of z in this case is going to be an ellipse. I hope you understood. So it will be an ellipse like this, okay? So if z moves on this ellipse, then this sum will always be k. This sum will always be k. This sum. If z comes inside this ellipse, then this sum will be less than k. If z goes outside this ellipse, then sum of its distances from z1 and z2 will be more than k, okay? So remember that. So locus of z is an ellipse whose foci will be at z1 and z2, all right? Whose foci will be at z1 and z2. And length of its major axis is equal to k, all right? That means 2a is equal to k. If length of major axis you are taking 2a, then 2a is equal to k. I'm comparing it with the standard ellipse, okay? So you can say that 2ae, distance between foci, this is 2ae, right? A standard ellipse. So I'm just taking the standard notation. 2ae, distance between foci, is equal to 2ae, which is basically mod of z1 minus z2, right? And 2a is equal to k. So you can find e also, eccentricity of the ellipse. Eccentricity of the ellipse is going to be mod of z1 minus z2 divided by k, okay? So if you divide this distance by sum of these two sides of the triangle, which is 2a, which is k, then you'll get the eccentricity, all right? Eccentricity. I hope it is clear. Now I'll give you the example on this, but before that, let's take the another case. If the same equation, if z satisfies I'm just uh, I'm just introducing a small change in the previous equation. Now what is that change? Z satisfies Z minus Z1 mod. You'll see everything is identical except one point. Z minus Z2 is equal to K, and K is now not greater than, K is equal to mod of Z1 minus Z2. Okay, K is equal to mod of Z1 minus Z2. All right, now what will happen? See, this point is Z1, this point is Z2, and Z lies here. See, now Z cannot be, distance between Z, sum of these two distances, if you take Z, if you make a triangle, then sum of these two distances cannot be equal to the third side. That happens. This is, K is the sum of two sides, right? In this triangle, you can see say K is sum of two sides, these two sides, and Z1 minus Z2 mod is the third side. Okay, the sum of two sides cannot be equal to the third side. That means Z1 and Z2 will not form a triangle. Otherwise, this will not happen, right? So if they are not forming a triangle, then where should we take Z? So that distance of Z from Z1 is equal to distance of Z from Z, distance of Z from Z1 plus distance of Z from Z2 is equal to distance between Z1 and Z2. So in this case, Z, locus of Z is this line basically, segment joining Z1 and Z2. If you take Z anywhere between Z1 and Z2, you can see this will be mod of Z minus Z1, and this distance will be mod of Z minus Z2, and their sum is going to be mod of Z1 minus Z2. All right, yeah, perfect. So you can write this equation like Z minus Z1 mod plus Z minus Z2 mod is equal to mod of Z1 minus Z2, but it won't be given in this way. It will be given, you will be given only this type of equation. You'll have to figure out that K is basically equal to mod of Z1 minus Z2. You need to figure it out. Okay, I'll give you the examples based on this. So in this case, locus of Z is segment joining Z1 and Z2. All right. Now let me give you some examples. The question is identify the locus of Z. All right. Identify the locus of Z. The question is if Z satisfies the first one is Z minus iota plus Z minus 5 iota is equal to 2. All right. Now this is the first curve, second, okay. Now you need to figure out, plot the locus of Z. Plot All right, so let's plot it. Okay, so you can see this distance of z from iota and distance of z from 5 iota is 6. What is this distance, by the way? This is your z1, right? This is your z1 and this is your z2. Now z is some, you take your z somewhere like this. So sum of this plus this. If I take this point P, then PA plus PB. So you can see PA plus, okay, this is PB plus PA is equal to 6. And what is the distance AB, by the way? This distance is 4 and AB is equal to 4. So yes, triangle will be formed because sum of two sides is greater than the third side. So P will lie on an ellipse. P will lie on an ellipse. Okay, so that will be the locus like this. So P will lie on this. Let's figure out the the other things of this ellipse. Suppose he is asking for the eccentricity. Okay, so what will be the eccentricity? You can see this. These are the foci. A, B are the foci. So 2AE. Okay, 2AE is equal to 4, and 2A is major axis. So major axis is how much? 6. All right. This is major axis. Okay, this is major axis, and distance between Z1 and Z2 is distance between foci, 2AE. So if you divide, then your E is going to be 4 by 6. 4 by 6 means 2 by 3. So you have got the major axis, all right. Now what is the center? If you need to write the center of the ellipse, the center is basically midpoint of foci. So this is 0, 5. This point is 0, 5. This point is 0, 1. So midpoint is going to be 0, 3. All right, 0, 3. Now suppose you need vertices. Okay, vertices, and this ellipse is a vertical ellipse, right? By the way, because you can see foci are lying on a vertical line, and this vertical line is nothing but y-axis in this case. All right, so it's an easy case. But still, anyways, we can always write center because we know the foci. Foci will be given Z1 and Z2. So center will be Z1 plus Z2 by 2. All right. Now suppose you need to write vertices. Vertices. Okay. So how to write vertices? This point. This point is, say, suppose C, and this point is D. All right. So we need to write C and D. We know the length of semi-major A, the value of A, right? So value of A, you know, is 3. So that means this distance is 3. This distance is 3. Distance from center. The center was 0, 3. All right. So this distance is 3 and this distance is also 3. Okay, so if you go 3 units upwards, then y coordinate will increase by 3, x coordinate will remain same, so 0 comma it will become 6, and if you go down then it will be 0 comma 0. So what is this are 0 comma 6 and 0 comma 0. So in this way you can write vertices also, you know. So you can answer, you can find b also semi major axis. Okay, using this formula, b square is equal to, b square is equal to a square 1 minus e square. Using this formula you can write b is equal to a. A means what? A means 3. Okay, so let's write 3 into 1 minus e square. E square is 4 by 9. Okay, so it is going to be 5 by 9, so 15 by 9. Okay, so b is going to be 15/9 and 2b is going to be 30 by 9. All right. All right, so we know everything about this ellipse. Now let's come to second part. Second part, you need to figure it out. Try this one. All right, let's figure it out. Okay, so now you can see your z1 is iota. Iota is somewhere. This is your iota, and 4 comma 4, 4 comma 4, 4 comma 4 is like this. 4 comma 4. This is your z2. So z1 and z2. And z is a complex number whose sum of distances from z1 and z2, these two, sum of these two is equal to 5. All right. So sum of these two distances is 5. What is the distance between z1 and z2? Let's figure out this one. So distance between z1 and z2 is also 5 because this point is 0 comma 1. So if you apply the distance formula, under root of 3 square plus 4 square is going to be 5. So if this point is say A and this point is B and this point is say P, then PA plus PB is equal to 5 and AB is also 5. That means PA plus PB is equal to AB. All right, so where will this P lies? Then this P lies on AB only. Okay, A. So that is the locus. This whole segment is the locus of P. It's not an ellipse in this case, right? So locus of P is segment AB, all right? AB. So AB is the locus of P. I hope it is clear. All right. I'll give you one example to solve. One minute. All right. Try this one. This is a very, very good question. Yes, some information of ellipse will be required, but that much, you know, basic. Even if you know a standard ellipse, you can do it easily. Z satisfies two curves. Z mod of Z plus 1 plus mod of Z minus 3 is equal to 6. So it might be a segment or it might be an ellipse, all right? or it might be nothing if the third case, if distance between the fixed points becomes greater than the distance between, I mean, sum of distances, then in that case z locus of z will not exist. All right. Z also satisfies z minus 3 mod is equal to 1. Okay, so this is a circle, right? You know that. Then possible values of that. So you need to see the intersection of these two curves. Okay, so z is satisfying two curves. Now you need to figure out how many intersection points will be there. Straight, right? All right, so I'm starting this. Wait a minute. All right. So you can see focus. This is -1 and this is 3. So -1 and 3, these are your Z1 and Z2. Z1 and Z2 is 3. Z2 is 3. And sum of distances of Z from these 2 points is given 6. So this sum is given 6, right? This sum. And what is the distance between these fixed points? That is 4, right? This is 4. So yes, locus of Z will be an ellipse. Let's say this point is P. So let's make the ellipse. So if I make the ellipse, complete this. Right, like this. So now you can see so Z lies on this green curve ellipse. All right, now this second curve is a circle whose center is at Z2 only 3 and radius is 1. So let's figure out first of all center of this ellipse is what, 2 comma 0. Yeah, 2 comma 0. no, sorry, 1 comma 0, 1 comma 0. And major axis length 2a is equal to 6, so a is equal to 3. So you'll get this vertex, say a is this vertex. So this vertex is going to be distance between center and vertex is how much? 3 units. So this should be 4 comma 0. All right, so this is 4 comma 0. So you can see this distance is 1. All right, so a circle is going to cut this meet this ellipse at A. Now you can make two types of diagram. Either you can make this circle will be like this, right? This might be the circle, one possibility, or this might be the circle. So you guess, not guess actually, you need to figure out which one is your correct answer, this or that. I mean circle, if second case, if this case happens second, this second case, and this first case. So in first case, you can see there will be 3 points of intersection, right? 3 possible values. But in the second case, this only one possibility. A will be the answer. You get the complex number as well. Okay. Okay, so I'm removing these circles first of all. I'll tell you how to check this. Do you know that in ellipse, which point is closest to this focus? Anyone choose any one of the focus? You know, this point A, vertex is closest to this focus. If I compare these distances, which seems, if I compare these distances, then these distances are basically in increasing order, all right? So S, this point is, what is, say this point is S, okay? So SA is the least, S closest point on the ellipse from S is A, all right? SA is least. If you know focal distance of any point, say this point is X comma Y, then in its standard curve, focal distance PS is basically X1 minus EX1, if you remember that. Sorry, A minus EX1, A minus EX1. This is for X square upon A square plus Y square upon B square is equal to 1. In this standard ellipse, this is the focal distance, A minus EX1, all right? So this A minus EX1 will be least when X1 is greatest, and X1 is greatest for this point A, all right? So these distances increases, okay? So if you make a circle, because most of the time we make wrong diagram of ellipse, so it is not easy to digest this diagram, that circle will be completely inside the ellipse. But yes, that is the actual diagram. Circle will be like this. It will touch the ellipse at A and it will be completely inside the ellipse. They also ask this question like, now find the equation of a smallest circle which whose center is at focus, one of the focus of the ellipse, and it touches the ellipse. So if center is at focus of the ellipse, then the smallest circle which touch this ellipse is this circle which I have made here. It will touch the ellipse at A, at one of the vertex, all right? So I hope it is clear. Now hyperbola is remaining. So I'll take hyperbola next in next session, and we will also do some examples based on ellipse, hyperbola, and parabola. All right, some more examples we'll do. So in hyperbola also there are very important points. So I wanted to discuss hyperbola separately because there are many points to remember in equation of hyperbola, and so that's why we will discuss it in the next session in detail. Okay, in detail. You need to know the standard conditions of hyperbola, like an ellipse. Like an ellipse, sum of if a variable point moves so that sum of its distances from two fixed points is constant. So in hyperbola, it is difference. If a point moves, so that some difference of its distances from two fixed points is constant, and also further, there's a condition on constant also. If that constant is less than the distance between fixed points, then that point moves on a hyperbola, variable point. Okay, and if it becomes if it becomes equal to the distance between fixed points, difference of distances is equal to distance between the fixed points, then it is not hyperbola. Then it becomes a line like this, or segments, or maybe rays. I'll tell you in next session. All right. And if it is greater than, then there's no locus. Okay. So I'll tell you these points in our next session. Till then, take care, and do not forget to like my video. Okay. If you are enjoying watching them, then please like them and use my code JEET1 if you want to take a subscription on Unacademy. As I told you, there are two subscriptions: Plus subscription and Iconic subscription. In Plus subscription, you get unlimited access to all the live sessions taken by top educators of India. You can follow anyone's course. It is up to you. You have complete freedom. It is unlimited access. Okay, so that is Plus subscription. And Iconic subscription, you are getting all the benefits of Plus, as well as personal attention, personal guidance of an expert, okay, for throughout your preparation. And you also get personalized feedback of your exam preparation. Okay, time management will be personalized. So that was Iconic subscription. All right, so you can buy any one of the subscription as per your requirement. Both are very good. All right, I have already told you the charges. Use this code JEET1 to get 10% discount, okay, in any of the subscription you want to take. All right, so thank you very much for attending this session. We'll continue in our next session. All right.